Alright, so for this problem we're supposed to be evaluating the limit as x approaches 0. Of course we can't just plug it right in, as would be the preference, because if we do, we'll be dividing by 0. So what we have to do here is we have to factor. So let's just kind of do a greatest common factor situation here. Divided by x cubed over 4x squared plus 3. So now that we've done this, I can cancel out these x cubed, and then I'm at a point where I can plug that 0 in. So as x approaches 0, the limit should equal, let's see here, up top that would give me 6, and down below that would give me 3. So that gives me 2. So my answer is D. Alright, on this problem they were very nice to give us the derivative already, so I don't have to take any derivatives. So at this point, just by kind of checking where is this equal to 0, I know that it's equal to 0 when x equals 2, 3, and 4. So what I'm going to do now is I'm just going to make my number line. And I've got my 3 points on here, 2, 3, and 4. And remember, I'm checking to see what is going on with the derivative at each one of these points. So I know that it's 0 here. Or rather, I'm checking the derivative in between these points, because I know these are the only critical points, these are the only places where it could be turning around. If I plug in like 2.5 here, if I plug in 2.5, I'm going to go back up here, that would be positive. That would be positive. It's always going to be positive because I'm squaring it. And this would be negative. So positive times a negative gives me a negative in between there. If I plug in 3.5, when I plug in 3.5, up here that's a negative. That would be positive here, and still negative here. So that would give me a negative in between here. When I plug in 1 over there, that would give me a negative here, positive here, and a negative here. So that gives me an overall positive value. And then when I plug in 4.5, that gives me positive, positive, and positive. So it would give me a positive here. So when I'm looking what's going on here, relative max at 2, that's correct because I'm going from positive to negative. Relative min at 3, there's nothing going on here at 3, so that is no. And then a relative max at 4, again, that we actually have a min here, so that's also a no. So your answer should be A, 1 only. So in this particular problem, we want to be looking at areas where the function is increasing and decreasing, or concave up or down. They kind of hand us these values, which is nice. If you look when we set the first derivative equal to 0, that's when the critical point then is x equals 1. Sorry for this little error right here. So what I want to look for is after that what's happening. So I can throw in a little test point like 2, for example. If I plug 2 into the derivative here, I do get a positive value out of it. So we're positive to the right here, so that automatically eliminates A and B. After that, I want to plug in a test point to the right of E. Now this might be kind of tough because you might not be able to evaluate 1 minus ln of 3 or 4 or something if you don't remember what those are. Remember, you can go extreme with it. If you plug in 1 minus ln of 1,000, that may be a little bit easier for you to evaluate and to realize that it's actually a pretty big number. So 1 minus that pretty big number would also be negative. So that's going to be negative to the right of E. So that's going to automatically eliminate D here. In case you weren't sure, so we'll C is the answer. In case you weren't sure, there's other reasons why we can eliminate E. As far as I'm concerned, most especially because C is definitely correct because of what I found. I'm not even going to spend too much time thinking about E because I see things in it that I just don't think I have to be concerned with, and I'm very confident in C. And that is the answer.